Hello, my fellow mathematician and the scientists. Welcome to this study, whereby we are considering conical frustum, which the top is closed and the bottom is also closed. So we are going to use similarities here to show how the surface area of the frustum can be calculated. Now here we have two triangles. So triangle P ST and triangle PQR are similar. So this is the triangle we are considering PST, and the triangle PQR are similar. So those triangles are similar. They are similar. So from similarity, if they are similar, it means that we can compare the radius. We can compare the radius of this triangle with the radius of the other one. So it means that capital R divided by small r is equal to, we can compare the height of this big one, which is given by x plus h, divided by the height of the big one, which is h. So that is the value we have. So from this, we can make h the subject of the formula by multiplying both sides by h. So we are going to have for capital R over small r h, which is equal to h plus h. So we subtract h both sides. We can subtract h both sides. We subtract h both sides to have r over r h minus h. Minus h is equal to x. Then from there we factor h both sides to be left with r over r minus r over r minus 1, which is equal to x, after factoring. So meaning that our h will be given by x divided by here we can write it as r minus r divided by r that way. Now from there this can be written as xr divided by r minus r. So that is the value of the h from that diagram, and using the similarity. So moving forward from there, linear scale factor will be given by r divided by capital R. Area scale factor will be given by r squared divided by capital R squared. Then surface area of small closed cone is by r L. Let me call it L. This one here, this length height, plus by r squared. Now surface area is given by the area of this circle with radius r plus the area of this curved surface. Here, where L, from Pythagoras theorem, L will be given by r squared plus is equal to r squared plus h squared square root of that from Pythagoras theorem. Now, surface area of the bigger cone will be given by surface area of bigger cone will be given by. So what you do, you multiply the area of the small cone with the area scale factor. So it will be given by r squared divided by r squared multiplied by rl plus by r squared. So you simply, once you get the surface area of the small cone, for the larger one, you multiply with the area scale factor. So surface area of the frustum, surface area of the conical frustum is, so it will be given by to r squared divided by capital R into bracket by rl plus by r squared minus by rl plus by r squared. So that is how you obtain the surface area of the conical frustum. Now in this case here now, we can decide to factor out some part. You can see pi r is everywhere, so we can factor pi r out from all this pi r to be left with r squared over r small bracket, this is bracket up to there, small bracket l plus r, close the bracket, minus l, we close the bracket. So we have factored this by r. That is what we obtain. Now if the frustum is closed both sides, so surface area will be given by, this is equal to by r squared over capital R squared bracket L plus R minus L plus by R squared. This is for a conical flask which is closed both sides. So for the cone which is closed both sides, you have to add this part here, because when you subtract, you are going to get the surface area of this part here less the side which is closed. So to take count of that, so that is where we are adding by r squared. Now, so that is how you can use area scale factor to obtain the surface area of a conical frustum which is closed both sides. Watch out for the numerical example which I'm going to give you in the next presentation. Thanks so much for watching this video. Remember to like, to subscribe, and also to share with the other mathematicians.